Hello friends, welcome back to the lecture 4 of the topic linear programming. So in this lecture what we are going to study, it's a linear programming with non-negativity constraints. Okay, see here, till this lecture number 3, what you have observed is we have taken only one and two non-inequalities. Okay, so from this class onwards we will be adding two more inequalities in that. Okay, so what those two more inequalities will be called as the non-negativity constraints. Okay, so let's see one example. With the help of this example I will try to illustrate this. So let's take one simple example. Find the graphical solution of the system of inequations. Find the graphical solution of the system of inequations okay, where they have given 2x plus y equals to 10 comma 2x minus y equals to 2 comma x is greater than or equals to 0 and y is greater than or equals to 0. Okay, so if you observe very carefully in this, this much part is what we have already covered in our previous classes. Okay, so this much part we have already covered. We have solved the graphical solution for the given two non-inequalities. Okay, now from this class onwards we will be adding the two more constraints, that are x is greater than or equals to 0 and y is greater than or equals to 0, and these are called as the non-negativity constraints. Okay, non-negativity constraints. Please make note that ये इतना बड़ा नॉन नेगेटिविटी कंस्टेंट क्यों बोला है भाई इसने. Why we cannot directly tell non negativity मतलब what? It's a positivity. Yes or no? So can I say it's a positivity constraints? If it is non-negative means what? It has to be positive constraints, yes or no? Of course not. Okay, we cannot say these non-negativity and the positivity constraints are same, because the non-negative means what? This constraint can include 0. This include 0. But when you say positive, this cannot include 0. Why? The positive is neither 0, the 0 is neither positive nor negative. So non-negative means what? 0 and all positive numbers. Yes, this is equals to the non-negativity. Positive means what? It's only positive numbers you will get in this case. Okay, so please make a note of this, that the constraints are non-negativity means what? This range is including the 0 itself, 0 or greater than 0. Okay, good. So let's try to get the graphical solution. Graphical matlab what we have to do? We have to take the Cartesian coordinates and we have to plot the lines, and let's check what is the common region in all these four. Okay, abhi lecture 3 tak we had only 2, now we have the 4 inequalities. Okay, let's see the first one. Let's take the first equation. So this is nothing but the first equation is what? It's a 2x plus y, it's equals to 10, and the second one is what? It's a 2x minus y equals to 2. Third one is what? It's x is greater than or equals to 0, and fourth is what? It's a y is greater than or equals to 0. Now let's have the space here. Let's first convert it into the double intercept form so that we'll directly get the x-intercept and y-intercept. So x by 5 plus y by 10, it's equals to 1. So we have the point x-intercept is 5 and y-intercept is 10. What about this second line? So it's x by 1 plus y by minus 2, it is equals to 1. Okay, and of course you cannot get the double intercept from this because x is greater than or equals to 0 and y is greater than or equals to 0 are itself. These are the solutions. Okay, let's plot the Cartesian form. So let's have the x-axis and the y-axis, x-axis, y-axis. So this is y, this is x. Let's plot this first line. So it is 5 on the x-axis. Suppose this is 5 on the x-axis. So it's 5 and 10 on the y-axis. Let's say this is a 10 on the y-axis. Let's draw a line passing through these 2 points. I will get the line something like this, and the step is what we have to do is we have to directly write the equation here. 2x plus y, it is equals to 10. Next line is what? This is the second line. So 1 on the x-axis. So suppose this is 1 on the x-axis and minus 2 on the y-axis. Minus 2 on the y-axis. Suppose we have here somewhere it is minus 2 on the y. So it is minus 2. It's a 1. So let's draw the line now. So this is how we get the line. Let's name this, which is nothing but 2x minus y equals to 2. Okay. Now get the feasible solution set for all these lines. First tell me, okay, let's have the different color. Let's take the purple. Okay, so 2x plus y equals to 10 means what? What is the feasible region for this? It's the line itself. Okay, so the each and every point on this line is a feasible solution set for the first line. For the second, as we don't have any less than or greater than, the solution set is what? The line itself. For second also, for second line also, it remains same. The solution set is what? It is the line itself. Okay, so let me draw. This is what the line itself. Second के लिए भी ये line itself. Okay, but for third, x is greater than or equals to 0 means what? You will get this as the feasible region for the third one. For third line, x is greater than or equals to 0. Now next is what? Y is greater than or equals to 0 means what? This will be the feasible region. For y is greater than or equals to 0, this is what the feasible region is. But if I combine all these 4 equations, because the system of inequation have all these 4 in a combination, so if I combine this, what will be the common region? And that's the graphical solution for this system of inequation. So common region क्या दिख रहा है आपको? So यहाँ से greater रहेगा and इसके नीचे and this part. So this part is nothing but the common to these 4 inequations. I hope you are getting this. See here, if you exceed this boundary, at least one of the equation will not satisfy. Okay, that's what we say that this is the feasible region for all given inequations. ये दो equations will get satisfied in this region and these two will also get satisfied in this region. Is it okay? So these are what equal to sign. So these are what the equal to sign will get satisfied on this and the greater than will get satisfied on this. Okay, good. So this is what we get. Now next see the next question. The next question says that find the graphical solution for the system of inequations which is 3x plus 4y is greater than or equals to 10. 3x plus 4y greater than or equals to 12. 2x plus y, 2x plus 5y greater than or equals to 10. X is greater than or equals to 0 and y is also greater than or equals to 0. See, again we have the 4 non-inequalities here. So let's take the equations one by one. So first step is what? Convert the given into the equations. So we get the first one as 3x plus 4y equals to 12. Second is what? 2x plus 5y equals to 10. X is, okay, let it be as it is because they don't create any problem here. Okay, so let's convert into the double intercept form. Step number 2 is what? So it's x by 12 by 3 is 4 plus y by 12 by 4 is 3, it's equals to 1. X by 5 plus y by 2 equals to 1. X is greater than or equals to 0, y is greater than or equals to 0. Let's plot these lines on the Cartesian form, Cartesian coordinates. So what you will get is y-axis, x-axis. Okay, let's have the space here. Okay, so first intercept is what? It's a 4 on the x-axis. Let's take this is a 4 on the x-axis, 4 on the x-axis, and 3 on the y-axis. So let's take this as a 3. Draw the line. Suppose this is what I get the line. Perfect. Write down the equation of line as it is. So it's a 3x plus 4y equals to 12. Next is 5 and 2. 5 on the x-axis. Suppose this is 5. 2 on the y-axis. Let's say this is a 2. Let's draw the line passing through these 2 points. Perfect. Okay, so write down the equation, which is nothing but 2x plus 5y, it is equals to 10. Now give me the common region, or let's have the common region first. So can we include the 0 0 for the first line? Can I have the 0 0 for the first line? Okay, so the step number 4 is what? Step number 4 is, let's substitute 0 0 and check whether the given equation is getting satisfied or not. In this equation, let's substitute 0 0. So it's a 3 into 0 plus 4 into 0 is greater than or equals to 12. So 0 is 0 greater than 12? No. Means what? 0 is not included in the solution set for the first line. So what will be the solution set? So the solution set will be, for the solution set for the first line is what? It's a above the region. So non-origin region will be the solution set. So this is what we get the solution set. Great. What about the second line? So if I substitute the 0.00 here in this equation, so I will get 2 into 0 plus 5 into 0, which is greater than or equals to 10. So 0 greater than or equals to 10. Is it true? No, of course not. So what I can say, for the second line also, I have the non-zero, non-origin solution set. Okay, this is what we get for the second line also. But because of these two constraints, my feasible region is getting bounded. So x is greater than or equals to 0 means what? Which is the set? So x is greater than or 0 means what? This will be the set. ये set हो गया अपना, x is greater than or equals to 0. Yes, perfect. And what about y is greater than 0? इसके लिए set आ गया अपना ये set आ गया. Okay, this is what the set for the fourth inequality. Now what is the common region for this? So anything right to the y-axis above this line, anything above this line, okay, let me draw this boundary, and anything above x-axis. Okay, this is what we get the common region for all of these 4 lines. So this is what the solution set for the given system of inequation. I hope you have understood this. Okay, so this is what my feasible solution is. Great. Okay, so nothing new in this here. We have just converted the given lines into the equations. We have plotted the equation and we have combined their feasible solution, and we get the combined feasible solution here. Okay, great. Now let's see some sort of new type of questions in this, where these questions are very popular, and these are the descriptive ones. Okay, so let me have the descriptive question here for you. Yeah, here we go. So let's zoom it and let's read this question. See, in this particular type of questions, what we need to do is, they will give the inequalities in terms of the text. See, this is what we have the question. Okay, oops, this is what we have the question. Okay, in terms of this whole big passage, they have given the inequalities. We have to derive the inequalities from this passage. Okay, so let's see how we can do that. A manufacturer produces two items, item A and B. Okay, so let's write down. Here we have the items. We have the item A and B, and both are processed on two machines, machine 1 and machine 2. So for this we have two machines, machine 1 and machine 2. Is it okay? Great. See, the item A needs 2 hours on machine 1 and 2 hours on machine 2, and B needs 3 hours on machine 1 and 1 hour on machine 2. Now how we will do, or how we will find out the inequality from this? Okay, see, it's very simple. What we have to do is write down the given items. Okay, I will elaborate this. Write down the given items here. So item A here and B here. Write down the machines. Okay, so machines. So how many machines you have? Machine 1 and machine 2. Okay, now let's rewrite the given information here in this table. You can say, see, item A needs 2 hours on machine 1. So item A needs 2 hours. So A needs 2 hours on machine 1. So it is what we get, the 2. Okay, so let's have our regular pen. So it's a 2 here. Good. And 2 hours on machine 2. So on machine 2 it requires again 2 hours. Okay, and item B needs 3 hours on machine 1. So यहाँ पे 3 आएगा, और machine 2 पे it requires 1 hour. Okay, it requires 1 hour on machine 2. Good. If any machine 1 can run for maximum 12 hours per day and machine 2 for 8 hours per day, maximum means what? It's maximum by machine 1 जो ना maximum 1 ही घंटा चलने वाला है. Okay, so how you will write the inequality from this sentence? Okay, so generally the inequalities lies in the last part of this segment. Okay, where you will find the inequality. So if machine 1 can run maximum 12 hours, matlab it can run for 1 hour, 2 hour, 3 hour, 4 hour, but it cannot exceed 12 hours. 13 hours it can it be working? No, 14 नहीं चलेगा भाई. मैक्सिमम 12 बोला है तो मैक्सिमम 12 घंटे ही चलेगा ये मशीन. ओके, एंड machine 2 will work for maximum of 8 hours. Good. So let, what we will write is let x and y be the hours machines A and B require. Let x and y be the hours, number of hours machines A and B require. Okay, so from this what equation you can form? So for item A you have for machine 1. So for machine 1 what is the equation? So A के लिए x है. So the for machine 1 what will be the equation? For machine 1 the equation it will be requiring 2x plus 3y. Okay, see, x is for number of hours for item A and y is for number of items B. Number of hours for items. Okay, this should be items, sorry, this should be items. Okay, on machine A and machine B. So 2x plus 3y is the total number of hours the machine A is working, and this should be the maximum of 12 hours. मतलब क्या आएगा भाई? लेस देन और इक्वल टू 12 आवर आएगा. ये हो गया मेरा मशीन 1 के लिए. What about machine 2 then? The machine 2 will be, so who will tell me the equation for this? The machine 2 will be what? It's a 2x plus single y. It's maximum 8 hours बोले, so it's less than or equals to 8. Okay, you can write x and y here also, no problem, x and y, so you will easily get. So here you can write the availability. What is the maximum availability you can have? For machine 1 you have maximum availability of 12 hours, and for machine 2 you have maximum availability of 8 hours. So you can simply write the equation like this. So it is 2x plus 3y is less than or equals to 2x plus 1y is again less than or equals to 8. So you can have the solution or the getting the inequalities in this way. Okay. Now what are the two more inequalities or the constraints you can have here is, as x and y are what? X and y are r's. They are r's, number of r's the item A require and B require. So they cannot be negative. Cannot be negative. So what you can see here is that x is greater than or equals to 0 and y is also greater than or equals to 0, as they cannot be negative but they can be 0. Okay, so this is what I get the first constraint C1, this is I get the second one, this is third, and this is the fourth. See how we have derived the inequality from the given passage. Okay, now let's take these constraints and let's have the feasible solution for this. Okay, so let me write all the constraints here. So it's a 2x plus 3y is less than or equals to 12, 2x plus y less than or equals to 8, x is greater than or equals to 0, y is also greater than or equals to 0. Okay, let's follow the steps, our normal steps, convert it into line. 2x plus 3y equals to 12, 2x plus y equals to 8, x is, leave them as it is. Okay, because they do not create any problem for us. Write down in the double interested form. So x divided by 6 plus y divided by 4 equals to 1, and x divided by 4 plus y by 8 equals to 1. X is greater than or equals to 0, y is greater than or equals to 0. Plot and check the region. Okay, let's directly check the region. Substitute 0 0 in this equation. So substitute 0 0 in this equation. So what you will get is 2 into 0 plus 3 into 0, which is less than or equals to 12. So 0 is less than or equals to 12. Is it okay? Is it correct? Yes, absolutely it is correct. So what I can say, the solution set for the first line includes the origin. Okay, so let's draw the figure first so that it will be easy to understand. So this is y-axis, this is what we get the x-axis, y-axis, double interested form. So what is our first equation is, so 6 on the x-axis, so let's take this as 6 on the x-axis, 4 on the y-axis. Okay, sorry, this is what we have, the 4 on the y-axis. Let's draw the figure. Okay, let me have the green line. Okay, let's have the figure here. Great, this is what I get, the straight line for the first inequality, which is nothing but 2x plus 3y, 2x plus 3y equals to 12. This is what I get the first line. Write down the second, 4 on the x-axis, 4 on the x-axis and 8 on the y-axis. So here if it is 4, okay, so here if it is 4, where will be the, so let me redraw the y-axis. Okay, so here if it is 4, here somewhere I will have the 8. Okay, so that 8 I was looking for. So 8 आ गया यहाँ पे. So let's join these two lines now. So let's join these two lines. So this is how the lines look. Oh, sorry, this should be straight line. Okay, assume this is a straight line. Okay, so this is what I get. What is the equation of this line is, it is 2x plus y equals to 8. Okay, now of course we have the constraints, non-negativity constraints are x greater than or equals to and y greater than or equals to 0. Now let's find out the solution set. For the first line we have proved that the solution set for the first line includes the origin. So this is what the first line is, and it includes the origin means what I will get is, I will get this region for the first line. It includes the origin. Okay, this is what I get, the region. What about second? So let's verify by substituting 0 0 here. So 0, 2 into 0 plus 0 less than or equals to 8. So 0 less than or equals to 8. Yes, is it okay? Yes, perfect. So the second inequality also getting satisfied. So for that also we have the solution set which is including the 0 for the second line as well. Okay, this is what the second line is. The next constraint is what? It is x is and y both are positive. Okay, so for them what will be the solution set is, so this will be the solution set. So let's have some different color. Okay, let's take orange. So this is what we get the solution set. This is what we get the solution set for all of these four. Okay, but in combination, if I combine all these four inequalities, what solution set I will get? So look for the common region of all these four. So this is how I get the common region for all. So here we go. This is what the solution set for the given inequation, system of inequation. What it indicates? What it indicates? So conclusion is very important. Okay, you take any point in this feasible region. You take any point in this feasible region and substitute in any of these four equations, that definitely will satisfy the given inequality. Okay, this is what the conclusion we can draw from this question. Okay, मतलब क्या है? You take any number of r's for atom A and B, it will definitely satisfy less than or equals to 10 and less than or equals to 8. Okay, so I hope you have understood these concepts and this question. So definitely, because we are explaining here, it is taking much more time, but don't worry, while we are looking for the exercise 7.2, we will be getting the solutions step by step and very effectively will get the feasible region. Okay, so stay tuned. With this we will stop here. Thank you.